Today, we're going to discuss the coordinate plane, the midpoint, and the distance formula. Just as points on a line can be identified with real numbers to form the coordinate line, points in a plane can be identified with ordered pairs of numbers to form the coordinate plane or Cartesian plane. To do this, we draw two perpendicular real lines that intersect at 0 on each line. So this is it. Is the x-axis and the y-axis. Usually, one line is horizontal with positive directions to the right and is called the x-axis. So the other line is vertical with positive directions upward and it's called the y-axis. The point of intersection of the x-axis and the y-axis is the origin, and the two axes divide the planes into four quadrants. So we have the first quadrant whose coordinates are positive and positive. On the second quadrant, we have negative and positive. On the third quadrant, we have negative, negative, and the fourth quadrant is positive and negative, as it is illustrated in this example in figure 2. So distance formula. So the distance between the points A and B in the plane whose points of A is x sub 1, y sub 1, and B whose points are x sub 2, y sub 2. So the distance now of AB is equal to the square root of the square of x sub 2 minus x sub 1 plus the square of the y sub 2 minus y sub 1. For example, which of the following points P or Q is closer to the point A as the points indicated? So as you can see here, point P is located at the quadrant 4, which is now whose coordinates is 1, negative 2. And point A is located at the first quadrant, whose coordinates are 5, 3, as well as the point Q is also in the first quadrant, whose coordinates is 8, 9. Now, to find which one is the closer point to A, now we're going to find the distance between the PA and the distance of QA. So we have the distance now of PA is equal to the square root of x sub 2 minus x sub 1, the square of this, plus the square of y sub 2 minus y sub 1 squared. So we are going to level this one. So your point P, whose coordinate is 1, negative 2. So I will write here that point P is 1, negative 2. Meaning to say, this is your x sub 1 is 1 and y sub 1 is negative 2. And the point A, shall we say point A is 5, 3. So we can let this one first as your x sub 2 and y sub 2. So meaning to say x sub 2 is 5 and y sub 2 is 3. So by substitution, we can write now the distance of PA. We have the square of x sub 2 here is 5 minus x sub 1 is 1, then close and then square plus y sub 2 is 3 minus y sub 1 is negative 2 and the square of that. Now simplifying, we have 5 minus 1 is 4 and then 4 squared plus 3 minus negative 2 is 5 and then square, so 5 squared. Simplify further, we have now 4 squared is 16 plus 5 squared is 25. And this will give us 16 plus 25. So the sum of 16 plus 25 is the square root of 41. So I will write now, so the square root of 41. So this is now the distance between P and A. Or Next is we're going to solve also the distance between QA or AQ. So I can write now as, so the distance of QA is equal to the square root of, okay, x sub 2 minus x sub 1 the square plus y sub 2 minus y sub 1 the square. So I will write first here the coordinates of Q, whose coordinates of Q is, we have 8, 9, and then your A is again, which is now 5, 3. So I will let this one now as, so point Q, I will represent Q as my third point. So I can write here as Q, whose coordinates is x sub 3 and y sub 3. So a while ago, I'm using A as my point, second point. So I will write A, whose coordinates is x sub 2, y sub 2. So in that sense, I can rewrite our formula as the square root of x sub 3 minus x sub 2, the square, plus y sub 3 minus y sub 2, the square. So by substitution, I can write now x sub 3 is 8. So we have the square root of 8 minus x sub 2, which is now 5. And then the square of this plus y sub 3 is 9. So I have 9 minus y sub 2 is 3. So we have 9 minus 3 and then the square of that. So simplifying that one, we have 8 minus 5 is 3. So 3 squared plus 9 minus 3 is 6. So we have 6 squared. Simplify further, 3 squared is 9 plus 6 squared is 36. So the sum of the radicands now, we have the square root of 45. So this is now the distance between Q and A. So the question is, we are asked which points between P and Q that is closer to the point A. So let's compare. So comparing the result of the distance of PA, which is now the square root of 41, and then the distance now of QA is equal to the square root of 45. So comparing these two distances between PA and QA, we could say that the closest to the point A is point P. So because square root of 41 is a smaller value compared to the square root of 45. So therefore, we could say that point P is closer to point A. Okay, next we have the midpoint formula. So the midpoint of the line segment from point A, whose coordinates is x sub 1, y sub 1, to point B, whose coordinates is x sub 2, y sub 2, is the sum of x sub 1 plus x sub 2 over 2. And in terms of y, we have y sub 1 plus y sub 2 over 2. So that is now the formula for a midpoint. So let us try to analyze this problem. Show that the quadrilateral with vertices point P, whose coordinates is 1, 2, point Q, whose coordinates is 4, 4, point R, whose coordinates is 5, 9, and point S, whose coordinates is 2, 7, is a parallelogram by providing that its two diagonals bisect each other. So if the two diagonals have the same midpoint, then they must bisect each other. So we are going to solve first. These are now are the diagonals. We have point PR and SQ. So if the value of their diagonals are the same, then it must bisect each other. So let us try to find now the midpoint of PR and SQ. So solving for the midpoint of, I will use capital M as the symbol for my midpoint. So I will use here the midpoint of PR. So I will use now x sub 1 plus x sub 2 over 2 comma, y sub 1 plus y sub 2 over 2. So we know that point P, whose coordinates is 1, 2, and point R, whose coordinates is 5, 9. So we can let now x sub 1 is 1 and x sub 2 is 5. It follows that x sub 2 is 2 and y sub 2 is 9. So by substitution, class, so we can write now as x sub 1 is 1 plus your x sub 2 is 5 over 2. Then in terms of y, we have y sub 1 is 2 plus y sub 2 is 9 all over 2. So simplify that further. What 1 plus 5 is 6. 6 divided by 2 is 3. And 2 plus 9 is 11. So 11 over 2 is not it's not a whole number. So we just write in terms of fraction. So the midpoint now of the line PR or the diagonal is 3 and 11, 2. Now, we solved the other diagonal line, which is now SQ. So therefore, I could write the midpoint now of SQ will be equal to x sub, I will use now x sub 3 plus x sub 4 over 2 and y sub 3 plus y sub 4 all over 2. I use x sub 3, x sub 4 to differentiate the point of PR. So in my example here, so my point 1 is in P, my point 2 is R, and my point 3 is S, and my point 4 is Q. So point S now, whose coordinates is 2, 7, and point Q is my fourth point, which is now whose coordinates is 4, 4. So by substitution, so x sub 3 now is 2 plus x sub 4 is 4 and then all over 2 comma and y sub 3 is 7 plus y sub 4 is 4 all over 2. So 2 plus 4 is 6. So 6 divided by 2 is 3. And the other one, 7 plus 4 is 11. So 11 over 2. So the midpoint now of SQ, whose coordinates is 3 and 11 over 2. Okay, the midpoint now of SQ is equal to 3, comma 11, 2. Since the midpoint of SQ is equal to the midpoint of PR, whose coordinates are the same, which is 3 and 11 over 2, therefore, we could say that the quadrilateral is a parallelogram.